So I think when you evaluate security, when you're looking at clouds, you need to understand your interface with the type of cloud that you're looking at. And here's what I mean by that. If we look at software as a service here on the left, and we look at Salesforce, for example, your interface with Salesforce is what? It's a browser. That's it. That's the only interface you have. You don't need to back it up. You don't need to patch it. You don't need to do anything. Salesforce takes care of everything. With a platform as a service, as I talked about earlier, you get involved with writing applications, and maybe you have some interface with some middleware or databases, right? As a back end to your web engines, whatever you need. But with an infrastructure as a service cloud, you have a lot more interaction. You have interaction to the guest OS layer, to the middleware, and to the application. And the cloud provider takes care of everything that isn't highlighted. So this really makes a difference when you're looking at the various clouds as to what the security parameters are that you need to look at. So let's talk about security in the public cloud, specifically in a public infrastructure as a service cloud. So best practices, of course, we all know this. Security should be implemented at every layer of the app architecture. We all know that. But what does that mean in a public infrastructure as a service cloud? Well, as the last slide showed us, there's certain things that are the vendor responsibility, but there's certain things that we as users are responsible for too. So vendor responsibility, facilities, physical security, physical infrastructure, all that kind of thing. If you've been out to the Terramark facility, way out in Northern Virginia, if you haven't been there, it is a very impressive facility. I swear it's more secure than Fort Knox, okay? You cannot get in. They've got 5 different feeds. They have enough oil to generate electricity for 60 days should electricity fail from one of their 4 providers. I mean, it's very, very secure. They take care of the facilities, they take care of the physical security, they take care of the infrastructure, the network, and even the virtualization. But guess what? All that stuff above that, that's our problem. Now we move on to your responsibilities, and these I find are very interesting. So you control the virtual machine in an infrastructure as a service public cloud. What does that mean? That means that you own the root or administrator password. You, not the cloud provider. What's the default Unix root admin that everybody uses? Change me. I know, I used to be a Unix admin. How many people have we found as admins out there, our users still have that same password after 6 months? Because they thought change me was easy to remember. I see some smiles, right? So it's up to us to make sure that our users change those username and passwords. You've got to change it. You are responsible for patching the OS and the application. You're responsible for everything up from the OS. There's a report coming out, I think it's coming out next month. I'm getting ready to blog about it because I'm so angry about it. This report talks about how insecure one of the public infrastructure as a service cloud providers is because they found so many operating systems that weren't patched and so many default root and administrator passwords that were still in use. And oh, by the way, also public-private keys that were out there on the web. So good report, good for us all to know that. My problem with the report is they're blaming the wrong people. It's not the public cloud provider's problem, it's our problem that we didn't change those things. Okay? Obviously you want to encrypt all data. I would encrypt everything before it left my facility, and I would use, in addition, an encrypted file system at the public provider. Users, understand credential management, right? Default passwords again, right? Consider two-factor authentication. I have my device, my little two-factor authentication device. They're $13. If you don't need that, I left my cell phone in the green room, but there is an application for the cell phone that you can use. So you do have two-factor authentication. I would definitely be using it. It's optional at most of the cloud providers, but I would be using it. And now we talk about something called security groups. So security groups are my favorite example of why it might actually be better to put your application in the public cloud than in your facility. Because most of us haven't implemented these in our facilities. Thank you. So what security groups do is they control all the inbound traffic. So what you can do, let's take a standard 3-tier application, a web tier, application tier, database tier, right? So in the upper left, right, I'm going to allow all HTML traffic into my web servers. As long as it's port 80, it comes in from anywhere. No other ports, but just port 80. In my app tier, however, other than an SSH link, because I need to get in and manage that server, the only traffic I'm going to allow has to come from one of my web servers. It cannot come from anywhere else. If it does, the firewall throws those bits on the floor. Conversely, consequently, whatever, when we go to the database server, the only thing that can talk to the database server, with the possible exception of maybe replication to another database somewhere else in another zone, because we're doing that for reliability and flexibility and agility, and maybe an SSH link because we need that to manage that server, is in fact the application servers. Nobody else. And those application servers can only access the database servers on a certain port. Now folks, I've been in a lot of data centers in my 9 years now with GTSI. I've never found a data center internal to a government organization that has implemented this inside of our facilities. What happens if you want to move to a public infrastructure as a service cloud? How do you design your application? Well, today, this is how our applications are designed. Right? Couple of web servers, couple of app servers, a database server, maybe some backups. They're all in one location, right? But if you really want to take advantage of flexibility, agility, reliability, and all those things that the public cloud offers you, just moving this application to the public cloud doesn't work. Your application, once you move this application to the public cloud, looks a lot more like that. Where I have everything replicated in multiple zones. So if a zone goes down here, I'm still up and running. Traffic is load balanced between those zones, right? I can do all of those kinds of things because of the flexibility and agility that the public cloud provider gives me.